This lesson is absolute value inequalities. Inequalities are when we say something is not equal to, we might be talking about greater than, which is symbolized by the arrow pointing to the right. Less than, which is shown by the symbol of it pointing to the left. If it has a bar underneath it, that means it actually could equal at that point. So, pointing to the right with the bar underneath it is greater than or equal to. Pointing to the left with the bar underneath it is less than or equal to. Now, if I was to actually color this in on a number line, the difference between the way this is going to look on a number line when I use it is I'm going to have an open circle, and greater than means I need to color to the right if x is on the left-hand side. Less than means I have an open circle, and I go to the left if x is on the right-hand side. So the big thing on these is we got to think about it with x being on the left-hand side. Now for the less than or equal to or greater than or equal to, the difference between those is it's actually going to be a filled-in spot and then shaded, either to the right or left, depending on greater than or less than. So the filled-in circle means I can actually be at that point versus the open circle, which says I can get really, really close, just kind of like that asymptote we talked about earlier, where we can be, I'm not touching you, I'm not touching you. Well, that's kind of what happens with the dot. An open dot is I'm getting very, very close, but I can't actually touch. A filled-in dot means I can be at that point. Let's practice a few problems. And the big thing on this is you have to memorize a trick. Less than is and. I can't write greater. Greater than or. And the way I always remembered it was great or than, and less than is and. I remember that or for greater. And that's going to help us with the next step. Just like with an equation, we had those two separate spots after we solved it to where that absolute value was the only thing on this side. Same thing's going to happen for our inequalities, except for we are now going to have and being the separator for less than, and or being the separator for greater than. So far we've only dealt with or. It was either this or that. Now, and on inequalities can show up with two different ways. You can actually write the word and have something like x is less than 7 and x is greater than 5. Or you could rewrite it to where you have your smallest number, which is going to be our 5, is less than x, which is less than 7. And these two things mean the exact same thing. And so that's just a compound inequality, but we are going to be using those in solving today's stuff. So, first off, we're going to write this as an and the and's the easy ones. We take our meat of our absolute value. We're going to put that in the center. 2x minus 5. Now, just like we had when we were dealing with the equal, we had the negative and positive of the number on the opposite. We're going to have the same thing. Negative is our smaller number, so it goes over here. The positive being our bigger goes over on the other side. And the reason I like to write my compound and inequalities this way is it makes it easier. When we're dealing with equations, we only have two sides. This time we have three sides. We have the very far left, the middle, and the right. So anything we do has to happen to all three spots. So if I add 5, I need to add 5 here and add 5 here. I'm just taking off that bar so it doesn't look like we're dividing. And so when I add 5 to each of those places, negative 7 plus 5 is a negative 2. It cancels out our 5's in the center because negative 5 plus 5 is 0. And I don't have to write it as 0. That leaves me with 2x. And all I'm doing is bringing down my symbol. And I have 7 plus 5, 12. Now I need to divide everything by my coefficient from my x, which in this case is 2. And that leaves me with negative 1 is less than x, which is less than 6. These are your sandwich inequalities. And when I do a number line, I don't actually draw out all my pieces. I draw in my 0 and my points. And so negative 1 is to the left of 0. Positive 6 is to the right. And when you're dealing with and, you're going to deal with a sandwich. It has to sandwich the two sides. And so there is no bar underneath, so it's an open circle. And if I read this, it says negative 1 is less than x. So x is everything I'm shading on my number line. So x, the smallest it can get to, is really close to that negative 1. And then it says x is less than 6. That means I can't go past that 6. Let's do one of our graders. We're going to do the greater than. So great or than means I need to put my or in the very center. And we're going to, unfortunately, we have to actually write it out twice. So 2x plus 3 is greater or than 15. On the other side, you're going to do 2x plus 3 is less than or equal to negative 15. So the signs both switch. Both those two signs have to switch. And then we're just going to solve each inequality individually. Just like you solve the equations individually in the last lesson. So I'm subtracting 3 from both sides so I can cancel out that 3. My inequality symbol, bring it on down, and that gives me a 12 and a 2x. Divide by 2, divide by 2. X is greater than or equal to 6. Let's work on this side. Negative 3. I'm going to positive 3, so I need to subtract 3 from both sides. This time I have negative 15 minus 3 give me negative 18. My inequality symbol just drops down. My 3's cancel out on the left-hand side, giving me 2x. Divide by 2. And then my inequality is x is less than or equal to -9. And so these are separated with the word or, so that means I'm either here or I'm here. Ors create wings when you graph them on a number line. Again, I'm going to plot my 0, and I'm going to plot my 6, and I'm going to plot my -9. I could actually fill in every other number on this too. I just don't, I'm trusting at this point y'all can draw a number line. And so, let's start off with x is greater than 6. Greater than or equal to. So that means I have a filled in dot this time. And if I'm greater than 6, that means I'm to the right of 6. Now let's face the other side. X is less than or equal to -9. So I have a filled in dot at -9. And then I'm going to shade to the left because it's less than. And then just a real quick reminder for absolute value, or just for inequalities, excuse me, not absolute value inequalities, just inequalities, period. If I am going to end up dividing or multiplying, meaning the number that's attached to my x, when I undo it, I'm going to undo it with either multiplication or division, with a negative number there. This side being negative, the one that's attached to the x being negative. It causes my inequality symbol to switch directions. So again, let me do another one just kind of like this. Let's say this time I have x divided by a -3 is less than 5. I need to undo this, so I'm going to multiply by -3 to both sides. And when I do, that causes that inequality symbol to switch direction. It's only if what you're doing to both sides is either multiplying or dividing by a negative number is when you do this. So it's only when this part here is negative.